My name is Gugulethu Mfuphi, and today we gathered here at the headquarters of Siemens in Africa, Midrand, Johannesburg specifically, to witness the launch of a new end-to-end power solution. Now, this is a distributed energy system which certainly hopes to address Africa's challenges and needs, as it's often been highlighted as being a very dark continent, given the challenges that it has in providing adequate energy and power solutions to its economies. Now, built on a system that is based on PV solar plants scattered across the Siemens campus, also managing in order to store a lot of this energy through its batteries, which are based in the basement, monitored and also implemented using technology via the Internet of Things. This is certainly a solution that we'll delve into to really understand what lessons we can learn from this innovative solution, and most importantly, how best it can be implemented across many more markets on the African continent. Let's engage with the CEO of Siemens Southern and Eastern Africa, Sabine Dall'Omo, to tell us more about this innovative power solution. Sabine, such a pleasure to have you with us today, and thank you for making time. I guess before we actually start with getting into the details of the distributed energy system, we probably need to understand the fact that Siemens, as a multinational company, has been invested on the African continent for years on end. At the same time, you've been able to witness the energy deficit that we also display on this continent, and as such, you've now come up with some solutions to actually meet to this challenge. Why now, and under what circumstances is Siemens implementing these solutions?
Well, thank you, Google, for having me today. But Siemens is in Africa since more than 150 years. South Africa was our starting point from which we ventured into the African market. But you ask about the power deficit, and it's very clear. When you look into Africa, you have about 600 million people which currently do not have access to electricity. And lacking electricity is one of the major disabler for the African society to participate in the global economy. Financing power projects in Africa is pretty expensive and it's difficult. The lack of funding is a big issue because a big power plant costs a couple of millions, 100 millions of euros. So many of the African countries do not have that financial capability to balance it on their government balance sheet. We were thinking about overhead lines might be a very expensive solution for a village, which is maybe an agricultural village only self-catering for themselves.
Sure.
So we looked at technology available, and as you have seen, you said that earlier you drove in here and you thought the solar panels are maybe only to keep the lights on now and then, but it is not the case. So solar definitely is one area where we had a significant interest in. And why is that so? Because when you supply power, you also need to look at the tariff. And over the last years, the price for solar panels came down significantly, specifically as the European countries embarked on a so-called energy transition. So there was more demand, and therefore the capacity increased, bringing down the prices for the individual panels.
Give us a quick walkthrough as to how you took an international, global solution and really tried to personalize it to the African environment.
We want to be carbon emission neutral by 2030, which is not so long away. It's only 12 years, so 11 and a half or so. Huh? So the challenge to contribute from each location to that goal gave us the inspiration to think about how can we do that. And in the ordinary course, if you get a corporate target, you might would think, well, we do some solar panels or we do some off-trading or so on, and then, target is met. But we, as we are in Africa, we think differently. And one reason to why we do that is because our underlying principle is business to society. We always think, how can we make most of what the challenges are for us? And that was one of them. We embarked on that proposal, and miraculously, and I must say, I would have expected more discussions. But in our company, as this is a fantastic idea, we got only support, and hence we could execute the project in less than 6 months.
Were there any challenges or hurdles that you might have experienced there? In a bit, we'll also obviously, unpack as to how best we can address some of those challenges to open up opportunities for the market.
Sure. So the South African market is pretty specific, and it's not really comparable to many of the markets which you see outside of South Africa, specifically in other African countries. But our challenge was, and this installation which we have here is just short of 1 megawatt. Why? Because currently the regulation of NERSA requires that if you go beyond 1 megawatt, you would need to have a license, which we obviously didn't want to apply for, and which would also would have delayed the project significantly. For us, it's really about the showcasing, demonstrating what our technology can do. And so we stayed short under 1 megawatt. And at this point in time, we do supply currently 800 kilowatt hours today. As you are sitting here, you will be able to see it outside. And that is about the consumption which we have in the moment. So everything we use, even including your cameras, are fed by renewable power. So that is actually quite a cool story, right? But there is a great opportunity specifically in the upcoming release of the draft IRP, which is currently in commenting phase and hopefully will be released very soon. So there, the regulator foresees, or the Department of Energy in South Africa foresees that limit is increased to 10 megawatts. And when you talk about 10 megawatts, you talk about many more applications which are possible. You can talk about industrial application, hospitals, bigger hotels, and so on. So there are many applications which all of a sudden make sense because you go beyond that 1 megawatt opportunity.
Let's come back to the Siemens campus, right? Literally everything, as you say, a majority of the factors that are being powered in this building are through renewable energy. Talk us through the CES system, because we've got the solar panels available, you've got the storage facility also available, you've got a microgrid that is also being managed, and this Internet of Things element that's also tied into the end. Monet, I understand, is what it's called.
Sure.
Give us a quick synopsis as to how it's all interconnected.
So, first of all, if you have a solar panel, traditionally one, you will have a little substation and you will have switchgear panels which then distributed into the consumer. So we have, with our microgrid controller, he manages all our assets. And at this point in time, before we had our solar power solution, we were also subject to many of the electricity cuts, right? And in the past, you would have seen we would have 2 diesel backup generators, which would switch on after a period of time. But now we have a solution, even if we would consume more than what the kilowatt hours are we get from the panels, maybe on a day when it's not as sunny as it is today, then we would be able, in the case of a power failure, to subsupply from these diesel generators with a flawless or a seamless connection. This is one of the benefits, for instance, our microgrid controller can assist with, and it manages all the assets which are connected to this PV solution, including all automation equipment related to it. Coming to Monet, Monet is our cloud control tool, and this is really Internet of Things and artificial intelligence to an extent, because with Monet we are able to forecast predictable what our power consumption will be. Weather forecast tool will be able exactly to say how much electricity we'll be able to produce on certain hours of the day. Or we can forecast, depending on occupation times, like on a Saturday in the morning or Monday evening, what the electricity consumption is of our site. How much power we can store in our battery solution, so that at times when we have power shortages or we have to supplement, we know exactly what we can use from that battery and how long it will last. But on the other hand, what is also very important is there are days where the sun is not sufficient and the battery might also not anymore sufficient to for the consumption which we have at that given point in time. So we will be able to forecast as well when we would be able to tap into cheaper tariffs by the municipality or by Eskom. So for instance, the city of Johannesburg has different tariffs for night consumption and for day consumption, for peak consumption.
Is this something that's new for Siemens being implemented, or is this something that is part of the international technologies that you've implemented in your systems before? And does it provide a bit of a competitive advantage when it comes to monitoring the energy use and consumption within your organization?
So first of all, this is first of its kind, and that's the first setup of that nature in a Siemens premises, so we're very proud. I hope that answers your first question.
Sure.
But the true benefit about it is that, first of all, you can make electricity consumption visible, and you can make sure that individuals like our employees consume responsible. Despite that it's maybe for free and it comes from the solar grid. But if you look at our savings, which we had so far, since the system is in operation, we have saved about 2 million rand in electricity costs because we could manage exactly these kind of fluctuations.
For those of us who are not very technically inclined when it comes to the measurement of just how much energy is actually being used of the 1 megawatts that's available for capacity? Bearing in mind that you've also got the diesel as a backup, you're also still connected to the grid to a certain point of view. How much electricity is actually consumed on the Siemens campus?
Well, currently we consume approximately 800 kilowatt hours.
For many of us, we're sitting here, we're thinking this is a fantastic solution. Of course, it's done by a global company, so the cost implication must be significant.
Well, it's still cheaper than any other form of electricity, and specifically because you could bring down the cost of the solar panels. And as you scale up your set out, you will be able to have also lower cost because the initial investment for the grid control as well as for the forecasting system is a one-time expense.
Mm-hmm. Sabine, I also want us to really get an understanding as to how this can be used as a case study for other businesses.
This is now a semi-industrial application. So because the reason why we have taken it for our Siemens premises is because we believe you need to consume your own product, right? It's very hard to sell it to somebody if you don't use it yourself. So that's really showcasing that we believe in our technology, and we really of the opinion that this is a benefit for many more than just our office park. But what the true benefit is, and specifically if you go into an industrial application, and as I said before, the new RRP will foresee that there will be a limit to 10 megawatts, which you can generate for your own consumption.
And that's a huge opportunity for Siemens, right?
Well, it's a huge opportunity for us, yeah, absolutely. If you take a hospital, and currently if you have a CT scanner, it would have a UPS, a unit which switches on when there is no power supply so that the unit is not damaged and can start operating. Say, for instance, if you have a scan, you do want to have it completed despite that there may be power shortages. And if you don't have a microgrid controller like we have here implemented, you will have cut-over times, and therefore you will have this UPS. But this UPS you only can use when there is a power shortage from the grid. So the grid cuts out, then this UPS will switch on and your equipment can function further. One of the big problems with the UPS systems, and independent how big it is, for instance, as a data center, they would have like a double redundancy of genset generators to ensure, maybe 8 or 10, to ensure that the data center is cooled and the data is still there because you want to still have access to your Facebook pictures, right? And with this kind of technology on a battery side, it's much more efficient because it's low maintenance and you can use it all the time. So it's not only a standby unit, and therefore your asset has a much higher appreciation to your value.
How is this enhanced productivity as well, including getting the buy-in of your staff to participate in such a project?
And we're a bit concerned about the tree huggers, that we will have a greenie revolution, but it wasn't the case. And the staff actually accepted this kind of technology welcoming, because this is what Siemens is about. That showcases what we do, and in an industrial application where we are, it's very hard to show what we're selling and what our business is about. So this kind of project really brings them close to what Siemens is about.
How can we actually unpack this to really understand the potential that it might have within a variety of communities and assisting with the socio-economic impact and positivity that we're looking for?
Sure. So if you look, for instance, at a PV installation, which we currently have here, and that is not unique to South Africa, but is rather applicable for all other areas in Africa, specifically where you have villages where people don't have a fixed income every day. So one opportunity which these kind of installations could have, that you would have an installation where electricity is produced in an area where there is a sunny space, right? And maybe the village would use half of that consumption or even less, and the rest they would be able to feed into the national grid, and on that feed-in tariff they would be able to generate an income for their community.
Just how does your system also connect to other forms of energy that might be able to be distributed or incorporated into the grid? I understand on the campus you've got diesel, you've got the main electricity supply from the main grid, and of course solar, but can you connect this to biomass, hydro, and many other forms of energy available too?
You can connect it to anything, and that is the smart idea behind the structure, because if you look into the energy demand in the future, it will be much more a hybrid type of solution where you have renewable energies, and because if you manage a grid, right, renewable energies cannot give you consistent electricity supply because it's fluctuating, so your grid will be also fluctuating. You do require this kind of balance, and therefore you would have, for instance, in a bigger application of a solar or wind application, you would have a gas-fired turbine which then gives you that balance in the grid to ensure that you have a stable grid going forward. You can do that for smaller industrial sites, because think about if you use a control system as we have right now, combined with a forecasting tool, Monet, which we have in application here. If you have an industrial application where maybe your second biggest input cost beside the labor is your electricity, and you work in an environment, for instance, where Eskom has a 25% increase, and now yesterday it was in the newspaper, they applied for another 15%. So you have all of a sudden 40% increase in production costs on one certain aspect of your income statement. You will be able really to control your input costs by managing your own power consumption and having exactly that kind of forecast mechanism to see what you need to take from the grid and how much you can basically produce with your own facility.
How can we find an opportunity perhaps to take CCAM as a microgrid? Is it scalable, number one, to address larger power supply needs? And most importantly, is it also an opportunity that we're missing here to actually implement scale and volume when it comes to electricity supply and power generation versus just one particular institution which is large and able to connect to multiple grids instead?
Absolutely. It's scalable to any size you would like to have. It is not only for smaller activities like 1 megawatt. You can scale it really to an industrial application, and that is the sweetness about it. But when it comes to the scale-up of the solution itself, so if you talk about a C-storage solution, a battery storage, that will help you. You can, as components, connect it to each other. So and then you can increase the number of units you will have, and the kilowatt hours or the megawatts you would be able to store. You can industrialize that for bigger operations to be self-sufficient.
Exactly. And hypothetically speaking, in a perfect world, if the regulation was in order, we'd be able to at least supply the main operators and the main grid back with power from the campus that's being generated here. But not too sure if you've been having conversations with regulators about that opportunity, have you?
Well, we haven't had, but I see in the audience is a representative of the German government, which is part of the energy partnership between Germany and South Africa. And in Germany, you can feed in excess power. So you can be a prosumer and not only a consumer. Yes. So you use when you need, and everything you do not need, you supply back into the grid, and then the utilities buy it for a favorable tariff and can use it then for the supply to any other consumers.
Happy to take your questions, thoughts and opinions on this rather critical theme that we are unpacking.
So on the saving side, you mentioned the 2 million rand. Mm-hmm. There's obviously two components, which is your cheap electricity in inverted commas from the solar, but also energy efficiency. How do you make sure that the focus doesn't move away from energy efficiency, because now you've got a cheaper electricity supplying your campus?
With regards to the energy efficiency, so what we obviously strive through is that we have low energy consuming units, and we had with our real estate department, we, for instance, replaced all light bulbs with energy efficient light bulbs. We did specific activities. If you look out here in our water feature, and if you ever have met or have seen the water feature before here in Siemens Park, you would have seen that we have a fast flowing river, which we reduced in speed. So we first of all could reduce the amount of chemical we put in, because now we have a natural cleaning system. But for instance, through that kind of mechanism, we also reduce the power we need, because we only need now a small pump, while we used before a quite big pump. So these are all the measures we would put forward to ensure that we still reduce our power consumptions.
The installation of the product, are they locally based? Are they manufactured here, or they are from international countries? Because currently in Africa, a main challenge is joblessness.
Yeah, with regards to the components, everything what we could buy locally, we bought locally. We engaged also with the installation companies, which have been local. But if you look at the panels, which was the biggest investment, then you will know that solar panels you only can buy from 2 countries in the moment, and that is China and South Korea. Asking your question on enterprise development or supplier development, or having suppliers feeding into our supply chain, this is one area where we are particularly proud of. And as you know, our BBBE level is a level 2 for an international company. This is a really great achievement, and we put a lot of effort on the development of companies where we are. And I would like to give you an example, which is currently not South Africa, but I will come back to this. So if I take our 14 gigawatt Egypt mega deal, which we did as Siemens 2 years ago, we have taken 160 small, medium companies with us. Out of the 160 companies, about half have been German companies, which had, through Siemens, the possibility to access an African market. And the other half, there have been companies which have been Egyptian companies, which we built up with that technology, which we're able to supply services and solutions into the market. And similarly, we like to do that in South Africa. We have a dedicated department, including our procurement department, looking into the development of companies. And what we do is we have a pact, a kind of a partnership, where we help companies not only to understand the technical requirement, but also make sure that they are in line with the legislation of South Africa when it comes to health and safety, when it comes to tax matters. And we assist companies as a close access of our business. Because why do we do that? Because we feel that if we are in a country, we only will be able to do business if everybody around us can do business. And therefore, you're more than welcome to engage with me afterwards.
Ma'am, just a clarification. In terms of the size of the panels that you guys are having here, the surface area, I just want to get some understanding to gauge it.
Okay.
But then the second thing, you say you've got 2 million rand savings. I just need to understand, is over what period is that? Is it since you installed, how long has that been? You know, how are you calculating that?
Sure.
Thanks.
With regards to the surface, we have about 700 megawatts on the parking lot and 300 kilowatts more or less on our solar panels on the roofs. On the savings, 2 million is in approximately 6 months. And it's a combination out of consumption, which we have from our panels, and cheaper supply through our battery from the night grid.
My question is more how the policy, the draft IRP and these kind of solutions comes to mind, or how they marry together. Because currently there's a license on the 1 megawatt, like you said. The draft IRP wants to raise that to 10 megawatt. The draft IRP also states that they will cap the amount of embedded generation to 200 megawatt. So there's a bit of a disconnect there because they're throttling the industry. And then further to that, my understanding is that as a country, we are currently installing anywhere between 300 and 500 megawatts of embedded generation per annum. But the IRP wants to limit that to 200. I was just wondering your thoughts on that.
First of all, I think it's a good proposition that it's increased to 10 megawatts. And I think these are exactly the different angles which are part of the period of the commenting period where we can put our input in. So currently the IRP is still in the draft form, and I would fully agree that it doesn't really make sense to limit it to 10 megawatts and then give a cap in totality. So I hope you have given that as a comment to the drafters, and that is part of the review before it goes into Parliament.
Is it not viable, perhaps, to consider the residential market? You know, we've got people who can afford, and those who are less fortunate. We know in the municipalities that holds Eskom so much money. Is there a way that Siemens can work with small businesses?
Exactly, that's the reason to why we have put up these demo unit, if you call it as such, because we want to make visible to the municipalities, to Eskom, what you can do and what the benefit can be. Because you're absolutely right. What is the point if you have a municipality which can't pay their bills, but there might be an area where they could generate their own electricity, and instead of having write-off, maybe have a combination of these kind of sorts so everybody is somehow helped. That's exactly the reason why we have put up the system, because we want to demonstrate to the potential customers and be more than willing to partner up with smaller companies, because you might have the access to these kind of consumers, to showcase what the benefit is of having a fully integrated distributed energy system, even on a smaller scale.
But how do we communicate this and share this with various stakeholders in the market to make sure that we do get the buy-in of City Power, of Eskom, of NERSA, and many other regulators in South Africa?
Sure. First of all, as I said just now, we want to use this facility as a showcase so that people really understand it's not just a solar panel installation, but it can do much more and can be much more effective in managing the electricity consumption, also for the ones which are selling the electricity, right? In South Africa, it will be a bit more challenging because we have a complex regulation, and it's not necessarily good just to talk to Eskom or talk to the city, because you have the regulator which still have to ensure that the electricity price is the lowest available to the consumer, and that is derived from the Constitution, sure, where electricity is a basic right. So that makes it a bit more challenging in South Africa, but we will try our channel through the Department of Energy, but also, for instance, during the investment summit now, which the President has called for in the next 3 days, to really exchange on these kind of opportunities, because investment is depending on that you have electricity available.
How can we, as stakeholders within the energy supply space, go back and share a different message about the kind of human capital we need to invest in to ensure that these mini-grids, alternative energy solutions, and of course the use of Internet of Things in enhancing how we distribute electricity is something that is kept top of mind? So clearly an electrical engineering degree is not enough anymore, but there are other talents and skills that we need to embark on.
Sure. First of all, I would think you need to be curious about saving the planet, yeah? Because it is really about reducing CO2 emissions, making electricity cheaper through resources which do not cost anything, like solar, like wind. But on the other hand, you do need to have an engineering degree. But if you look, for instance, into some of the applications specifically which you can use on your cell phone as an app, you might do not have to go that far, but you need to be curious about keeping math and science, and specifically the application thereof, on your mind. And we will help you. I think the world, specifically in the educational environment, is changing so fast that we would offer, as well as a company, to step into our company, maybe with a degree, maybe with not a complete degree, to assist you to understand what we are doing, starting loving our technology, and then finding ways on how to implement that.
Sabine, it's been such a pleasure engaging with you and really trying to understand more about this new innovative technology that's available. And of course to you, our audience that has joined us today, giving us key questions and sharing your insight into some of the challenges and of course the opportunities that do exist. You will have an opportunity obviously to witness this firsthand by going on a tour with some of the representatives here at Siemens today. It's been a pleasure being with you, and thank you so much for joining us for this edition of Siemens Dialogues. Thank you so much.